Perfect. So we'll move along and we'll get to the next presentation. So the next one, it will be a good one. Also from a former colleague of mine, Dima Kassab, that is now working at Google from a customer engineering perspective, and our colleague Muneeb Master, also from the hybrid cloud specialist at Google. So if you don't mind, Dima and Muneeb, take it over.
Hello, everyone, and welcome to our talk on an approach for configuration management in multi-cluster environments using Anthos. My name is Muneeb Master. I'm a customer engineer with Google Cloud, and I have with me my wonderful colleague, Dima Kassab. Dima, you want to introduce yourself?
Yes, sure. Hi, everyone. This is Dima, and I'm also a customer engineer in Google Cloud.
All right, so let's get started by considering some of the challenges with managing configuration across multiple clusters, across different cloud environments, or even in hybrid environments where some of your clusters are in the cloud and some are on-prem. The first one is consistency, and that's about ensuring consistent security and access control policy across clusters and environments. Next is scalability. How do you automate policy and security at scale in multiple clusters and propagate those changes quickly? And finally, there's visibility. Like, can you have a centralized and auditable configuration tracking system without losing too much flexibility? That's where Anthos Config Management, or ACM for short, can be used to address and solve for some of those challenges. ACM provides a unified management experience across environments, whether it's on-prem or in the cloud. It enables platform operators to manage infrastructure and platform lifecycle. It enables service operators to use defined landing zones and inheritance to manage services and workloads. And it enables security operators to create and enforce policies using governance tools in place of pod security policies. And it does all of this using a modern DevOps workflow. Now, ACM is actually comprised of 3 components that we're going to be covering today. The first one is config sync, and we'll deep dive a bit more into each of these. We're starting with config sync, which is configuration as code. And what it does is it basically synchronizes the state of your clusters with your Git repository. So typically what we still see on a pretty regular basis is that a lot of teams are still using kubectl to apply changes to their environments. And so they're still doing things in a very imperative, using very imperative operations. And this is challenging because as these clusters grow, not only in number, but in scale and size, it becomes difficult for operator teams to sort of continue to use kubectl or imperative approaches because Kubernetes itself is a declarative system. In Kubernetes, you declare what you want the state of the cluster to be, and you push that configuration, but that doesn't really match up to imperative operations. So how do you transition that sort of imperative approach to one that fits Kubernetes model better, that's more declarative in nature? I mean, you could use declaration, like Kubernetes manifest files, and apply those in a declarative fashion, but that doesn't really go well with the Gitops model. So the first step is we take out that imperative approach and replace it with a central repository where you store that configuration information. You start with a Git repo that almost every technical practitioner is familiar with. And inside that Git repo, you store all of the configuration about your cluster, how you configure your namespaces, any RBAC policies, resource quota, security policies, you name it. If it's a Kubernetes object, it can fit in that config repo. And what we're doing with that is we're trying to create this sort of approach where the state of the cluster is what exactly matches the state of the repository. So if it's not in your Git repo, it's not reflected in your cluster as well. So ACM enables that by giving you the ability to find the state of your deployment and store that in the central secure Git repository. So the benefits of that are the same that apply to typical software development. And that's the ability to have audit changes a lot more cleanly. If somebody makes a change that you need to roll back, you can revert a commit. And it also gives you the ability to do things like if you need to create a staging site that looks like prod, you can create a new branch, for example. And the config management is also self-healing, so it watches the cluster for drift from the configuration. So if somebody does an imperative change, Anthos Config Management will actually fix the drift and put things back to its declared state. And ultimately, the best part is that you can also version your deployments, just like you version software. So you can tag them, mark them as release candidates, etc. Git becomes your source of truth for all of your cluster configurations. And that configuration is declarative and expressed in native YAML formats. So on the right here, I have an example of a Git repo structure for a cluster configuration or multiple cluster configurations. And this structure can actually be generated using a command line tool called Nomos. And you can even use Nomos for other things like checking for syntax errors using like client-side or server-side hooks, which we'll look into a little bit later. Once your cluster configuration repository is set up and secured, and you want to apply it to your clusters, you deploy the ACM operator on your cluster, and then ACM syncs the cluster configurations with the repo. You can also use what's called cluster selectors to limit which clusters a particular configuration applies to based on the cluster's labels. So for example, if you only want to apply a change to a dev cluster and not to a prod cluster, that's where the cluster selector can be used to limit which clusters that change applies to. And also, ACM supports namespaces and inheritance of namespaces so that, for example, if you want to apply an RBAC policy to multiple namespaces like the front end and the back end in this example, you could then put that RBAC policy in the abstract namespace shown here called online, and any namespaces that inherit from that abstract namespace will have that same policy applied to it. So that covers the config sync component of ACM. And I'll now hand it off to Dima to talk about the policy controller and the config connector.
Okay, great. Thanks, Muneeb. So yeah, I'm going to talk about the policy controller, and this is the piece in ACM that will make sure that your policies are enforced across all your environments. So before we talk about what that controller look like, you're probably wondering what's the difference between config management and policy management. So policy and config management are definitely related, but they're not the same. So config management is more concerned with the deployment configurations. So there is a process, for example, for how it's done. As we've seen with ACM, that's kind of Gitops model. And then for who can do it. So that's something we can do, for example, with RBAC. So config management focuses more on the state of the resources. On the other hand, the policy management is more about defining rules and enforcing these rules. So it does examine what the change is and whether it's actually allowed or not. So if we take, for example, an RBAC policy for a deployment, so in this case, you can, using RBAC, set who can actually make changes to the deployment. On the other hand, what the policy management and control will let you do is before even that, like using something like a required label, is that a change that that person is trying to do is allowed? So in this example, if that deployment doesn't have specific labels, that deployment is not going to be, or that change is not going to be allowed to start with. So I hope that clarified a little bit the difference between the two. So as I said, with ACM, we have a policy controller. And what that is, it's a Kubernetes dynamic admission controller that will check as well as audit and enforce any cluster compliances with policies that relate to your security regulations, or even any arbitrary business rules. So as I said, for example, that required label policy that you might want to enforce. So the policy controller is built from Gatekeeper, which is also part of the open policy agent. And then it also does give you the ability to test these policies before enforcing them. So in general, you can set these policies in your ACM repository, and then GKE will take these policies and then talking with the policy controller, check if any of the changes that's being requested to be made is allowed or not. So if it's not allowed, it can reject these changes. So to do that, we need to define these rules. So this is where we have that policy structure in place, which we call it the templates. So the template will allow you to define how a constraint works, and then gives you the ability to delegate defining that constraint and the specifics of that constraint to a different group or different individual who have the subject matter expertise to decide what that constraint should look like. So ACM does come with a predefined set of templates for common use cases, just to make it easy for you. But then you can also write your own templates using Rego. As I heard, it's a little bit difficult to use Rego, so that's why we provide that predefined template library that you can use. But in addition to that, you can also use some of the open source available policies templates. So once you define this constraint template, now we can instantiate specific policies or specific constraints from it. So just on the right here, we have one example of that, and this is just a template for enabling MTLS. So as I said, now we have that template. Now we can create that specific constraint from it. So as you notice first here, this is just really straight YAML file. So it's going to be more familiar for the operators to use it. And what we are defining here in specific is, what the policy we are trying to do. So it is TLS enabled, but then to which resources. So that's our destination rule, and then to which namespaces. So in this case, default. We also defining what action we want to take in case this constraint is violated. And in this case, it is deny. So the other option we have is just to audit that change and notify that that constraint has been violated. So what happened then? Once in this example, someone is trying to create that destination rule. Notice how it's also in the default namespaces, but it has that TLS disabled, and that's why the policy controller is going to deny the admission of this object. So that destination rule is not going to be created. So that was the policy controller piece. And let's talk now about the config connector. So what config connector is, it's also a Kubernetes extension, which enables you to manage Google Cloud resources through Kubernetes configurations. So in this case, you can use just your regular kubectl or the Kubernetes API to provision Google Cloud infrastructure. So in a similar way to Kubernetes, you will just simply specify your intended state through a declarative configuration, which actually I should mention here that you can just simply include in your ACM repository. And then config connector will take care of creating that object for you in Google Cloud. So to put it all together, what we have here, we first have our configurations and policies that we are going to check in our Git repository. And then ACM will take care of syncing these policies and configurations if they are validated. So that's where the policy controller piece comes in place. So if something is not validated based on some policies we did request, it's not going to be passing that admission controller. In addition to that, the config connector will take care of creating any resources that you requested through Kubernetes. So we can have here, for example, a request to create a MySQL, and then config connector will take care of creating that. So I hope this clarifies also what config connector is.
Thank you for putting it all together, Dima. But now can we show how all this actually works?
Yeah, absolutely. So actually, I've been working on a demo where I have this application. It's Bank of Anthos. that I wanted to deploy to different clusters. So as you notice here, I want to put all these different pieces in different namespaces, and I want to set things like different quotas for them and different network policies. So what I have also included is actually your Anthos box. So that's my GKE on-prem. And then in addition to that, I added other GKE clusters, as you can see here. So the way I'm doing this, I'm using GitLab, and then I have repos for my application code, but then I also have a repo for my configurations and policies. That's where I'm leveraging ACM to make sure that I have the policies enforced on all these different clusters running in different environments.
So you've got the 4 GKE clusters, and one of them is running on my little Anthos box, and then the other 3 are running in GCP. Can you show us how those clusters look in the Google Cloud Console?
Yep, yeah, absolutely. That's my dashboard for Anthos. So as you can see here, I have the 4 clusters registered with Anthos. And then what I did next is for each clusters, I did set up the ACM operator. And then as you can see, I'm syncing all of these clusters to a repo. So let's take a look at what that is. So as you can see here, it's my Anthos Config Management repo running in GitLab.
Can we take a look at what that repo looks like?
Yeah, absolutely. So notice here, it's very similar to what you've shown us earlier with the Anthos Configuration Management. So we have, the cluster registry, and then the namespaces. So let me show you a little bit more the namespaces stuff. So this is where I have my the Anthos, the Bank of Anthos application. So let's look at the ledger. So notice, for example, that I have different policies in here. I have the quota, I have a network policy, as well as I do have here the GitLab runners. So what I'm doing here, I'm leveraging ACM to actually set up the configurations for the GitLab runners. So once, I add the cluster, GitLab runner is working, and then I can simply come and run my deployment pipeline, and that will deploy the Bank of Anthos to my clusters.
So can we double click on one of those policies, like the network policy, for example?
Yeah, absolutely. So actually, I meant to make a change here just to enable traffic from the Bank of Anthos front end. So I'm just going to cheat and do it from here. So let's, oops. Sorry. Awesome. So let's just commit the changes. And what this will do, actually, I have a pipeline set up. So let's take a look at that. So it's still pending.
Oh, I see here you've got the vet step. So is that actually using the Nomos hook to do the vetting?
Exactly, you're absolutely right. So I'm making sure that, I don't have any syntax errors. I don't want to, get all the way to the end and then I have some syntax errors. So that's exactly what I'm doing.
Looks like it's done. So if we go back to a cluster, it should be changed, right?
Yep, notice here that we have now that name selector added, and then actually let's take a look at another cluster. So we looked at the GKE on-prem. Let's look at the staging, for example. And then same here. Notice how the changes also are applied here.
That's pretty cool. And what did the validate step actually do?
Yeah, this is actually pretty cool. Let's go back and take a look. So notice here it did pass. However, I have an example where that didn't pass. Let me just pull that. It's actually this one. So notice here that we got an error because type spanner instance is not allowed. And what's only allowed is the SQL databases stuff, okay? And the reason this happened is because I do have in my repo, I have a policy to only allow MySQL. So let's take a look at that. So notice here that, I'm just enforcing that policy. So what I did in the validate step, let's actually take a look at that as well. So I'm using that gatekeeper validate. So any policies that are defined, gatekeeper validate is going to make sure that they're compliant, and if not, that step is going to pass before even getting to deploying it. With that said, also, like, even if, let's say, we don't have this step, the policy controller running in the cluster will still reject that, so it won't get that instance created.
So what about creating a MySQL instance since that was allowed?
Yeah, definitely. Let's actually do that. So let me go back here, and then in order to do that, we need to actually create that instance in the project namespace. So that's the same project name I'm using where the instance is going to land. I'm just going to cheat here and then create this. So let's just call it mysql.yam. Oops, sorry. And then
this is actually going to use config connector to create a MySQL instance in GCP? Yep,
exactly. You're absolutely right. So this will again go through the same pipeline, and then once that succeeded, it will create the instance. So let's come here and just give it a little bit of time, and then we can refresh, and that should get that instance created. So as you notice now, that will started our Bank of Anthos instance for MySQL. So yeah, that was using config connector.
Okay, that's pretty cool.
The source code for this is available on our GitHub, so you can actually go ahead and try it for yourself, and try it on your specific use case.
And we also encourage people to take a look at the ACM documentation at cloud.google.com, right?
Yep, exactly. Yeah. And yeah, I hope you guys enjoyed this presentation and the demo. And please don't hesitate to reach out if you have any questions.
Thank you, Dima and Muneeb. We have from the audience 2 questions. The first is, does policy...
And please don't hesitate.
Sorry, go ahead. The first is, does policy controller have any governance controls around approvals? In particular, can I stage policies and force specified approvers for staging separately from production? And can I do that by cluster and/or namespace?
Right, can you hear me?
Yep, can hear you okay.
Okay. Yeah, so the way we do it, and we didn't show that in the demo. So normally what you would have a different branch where you are testing these policies. So with that validate step, it can go through that all the policies, and then if that controller, if the resource you're trying to create doesn't match the policies we have, it will not allow that. So in that case, we're relying on that pull request. So if you don't merge it with that master, then it's not going to be applied to the cluster. So what I'm trying to say here that, when you sync your policies and your configurations, we do specify which folder in GitHub, which branch in GitHub you'll be syncing with. Now, in terms of the namespaces, so what we have here, you can also rely on the GitHub, so you can give access to specific folders based on the namespaces. So let's say, a specific team need access to only their namespaces, then you give them access to make changes only to these folders in the ACM repo.
Perfect. We've got 2 more here, unless more come in the meantime. What about how does sync compare to Flux for managing declarative configurations? And when might I choose ACM over Flux or Flux over ACM?
Muneeb, do you want to jump in, or maybe let me take a first pass at this. So yeah, so the difference between the two, I would say, it's a very similar model. So both rely on that GitOps model where you have, that source of truth, and then you are syncing with it. ACM focus more on the policy and the configurations, while Flux focus more on the deployment end. So that's why, for example, with the hierarchy of the ACM repo, that's why you can have these abstract namespaces, and you can put different policies to apply them now into all different namespaces at the same time. The other stuff that ACM is different, and again, it's more focused on the policy piece, is that the OPA gatekeeper. So it's kind of by default is included in an ACM. And then config connector, I would say that's another differentiator, where kind of, I don't want to say differentiator, it's just a different model, where we are also including that ability to create cloud resources through ACM. So in this case, it's more on the managed end for you, so you'll just have it set up. And then having that centralized repo and the cluster registry concept and selector, where I can, from that same centralized repo, I can just say, I have some policies I want to apply here, and not different policies. Now, with that said, I haven't looked at Flux recently, but again, we have clients who would use, like Flux or Argo CD for their deployment pipeline for the applications, and then use ACM for that policy and configuration piece.
Perfect. And
So just to add, can you hear me? This is Muneeb. Yeah, just to add to what Dima said. So that's right. ACM does have some additional security features versus Flux and Argo. I think the idea here is that ACM is intended to provide more of a consistent and integrated experience for like enterprises and multi-cloud and hybrid platforms, because it plays well with the rest of the Anthos platform, right, altogether. That's the idea there.
I think that segues nicely into the next question as well. Can I run this on Azure and AWS, or is it GCP only? And can I run it in in-house clusters?
Should I take that, Dima?
Yeah, if you want, or I can go first.
Go ahead. Yeah.
Okay. Yeah. So just to kind of, I didn't catch the last part. So the first part of the question was AWS and Azure, correct?
In AWS, Azure, and in-house, I guess, would be
something like with OpenShift or yeah. Okay. Yeah. So yes, definitely. So if these clusters are registered with Anthos, same way, you can have the ACM enabled on these clusters, and then we will sync the policies to these clusters. So yeah. So the concept of that in-house cluster, that's going to be bring your own cluster, or you bring your own Kubernetes part of Anthos. So same way, you register these clusters with Anthos, and then you give them the permission to access the repository, and then we will sync the configurations and the policy piece with these clusters. With that said, though, config connector at the moment create only cloud resources in GCP.
I think I'm just looking over the QA in the chat. I think that's all the questions we had. So what I'm going to do is I'm going to pass this over to Julia for some quick remarks. Thank you, Dima.
Thank you so much for organizing this.